In this presentation, I'm going to talk about what theories and hypotheses are, how they're related, and how they get used in scientific explanation and what I like to call scientific storytelling. Now, what do I mean by that last thing, scientific storytelling? Very often, what we're trying to do is tell a story about the world. And that's the simple, kind of the informal way of saying we're trying to explain the world, right? Because if you think about what a story is a chain of causally linked events. This happened, and then that happened, and then that happened, and we get to the end. And so stories, a good story contains all the steps that lead to the ending. And one could argue it leaves out a lot of other things, right, that don't matter. And that's, a good explanation of what goes into a theory. Because a theory is basically an explanation of a phenomenon, right? We get to use words like that, phenomena, and phenomenon. And those things are just things we observe, okay? Things that happen in the world. And so a theory is an explanation of a phenomenon based on some underlying, perhaps unobserved phenomenon, right? And so, I'm sorry, I got to go. Phenomena, all right, sorry, I had to do that. But that's the story. So this is very important, though. We're very interested in causal links, finding out what makes the world work. I often describe it kind of in the movie The Matrix, right? When Neo is in the artificial world and he finally starts perceiving the code running behind the walls and behind the bullet coming for him, and he has this moment where he sees through and he perceives the code behind what you see. And I always say, to a very limited extent, when we're doing theories, we're trying to get through all the stuff you see, because there's so much information about the world out there, so many different things to take into account, that you're trying to pick out what are the real causal links. And with causality, it's basically if A causes B, then if not A, probably not B. And so we want to get to what really matters. So that's really what theories are, in kind of an informal way. That's the key intuition you should get about what theories are and their role here. Now, okay, so I've been informal. Let's get erudite here. And Carl Hempel is a physical scientist, and maybe a lot of political scientists, we like to emphasize the science part, and so we're social scientists, but we try to be scientific. So Carl Hempel was a physical scientist who talked about theories, and here's his definition: that theories seek to explain empirical regularities by explaining them as manifestations of entities and processes that lie behind or beneath them, as it were. I'll close the quote and say that's what I mean about, we're trying to get behind things, what's under the surface. To get back to his quote, these are assumed to be governed by characteristic theoretical laws. Close that quote for a second. What's that mean? Well, we tend to think that what happened, that there's generalizations, and political scientists and social scientists in general are really big into generalizations. We like to say, look, if an arms race caused World War I, well, arms races should then cause wars more generally, right? So we're looking for this generalization. And when we study things, we're always trying to generalize the phenomena. It's not World War I, it's a war, or maybe it's a category of war. They frequently talk about hegemonic wars as being, a separate category, but we're categorizing and generalizing. That is we take that from the sciences, who figure that one molecule acts like another. And if the temperature goes up one day, the molecules, how they act that day will be the same if it goes up another day. I labor this point because this is a big difference between political scientists and historians. Historians usually explain an event in terms of its own characteristics, and each event, World War I has to be understood as an event unto itself. And there we totally part company with historians. Although historians, political scientists often point out, historians make a lot of generalizations in their conclusions, even while they're saying, oh, everything's unique. Back to the quote. So we're assuming that they're governed by characteristics, and by means of which the theory explains empirical uniformities that have been previously discovered, and usually also predicts new regularities of similar kinds. What's that about? In the physical sciences, very often what you do is you observe some empirical regularity. Water boils at a different temperature at different altitudes. That's an empirical regularity. It becomes observed. And when you have an empirical regularity, it's called a law. Right? So laws of science or laws of physics are just things behave a certain way. The question is, why does water boil at a different temperature at different altitudes? Well, the scientists have looked at it and they've experimented and they figured out that what it is, it's different air pressure. Right? And they tested that by taking stuff at one altitude, in the lab and putting it in a vacuum, putting it in a chamber, lowering the air pressure and seeing, does it boil at the same air pressure that you would find at 16,000 feet at the temperature it would boil at 16,000 feet? Oh, lo and behold, it does. Okay. And so, but see, now they've explained this thing we see, that water boils at different temperatures at different altitudes. They've explained it in terms of something that was originally unobserved, although it was observed, but it wasn't connected, right? The idea that, hey, it's the air pressure that's different. So also when you discover things like the air pressure makes a difference, you start being able to say, well, what would happen in outer space? Or what would happen, in places that have different temperatures that maybe we've never observed before, right? And so we can start predicting in different locations, in different situations, how water would boil, right? And okay, that's water boiling, but this is the scientific role of theories, is to provide an explanation, generally in science, for things you see, have observed regularities, and you explain some of the things you see, but then you develop new predictions and you're able to explain new things. And so there's very much this idea, we want to explain what we've seen, but we want to be predictive. We want to be able to explain things in different contexts, right? Different situations, because that's the future. Okay, there often are competing explanations, and I like to just say, look, a theory is an explanation. And one example, also, I want to point out that you'll study in IR all these grand theories. There's realism and liberalism, which is a hollow term because there's so many flavors of liberalism. But there's, neoliberal institutionalism and the democratic peace, which is theory. There's all different theories under liberalism. They have these grand names. But in general, theories are simply explanations. And when you have an explanation for something, you're basically working off of a theory, whether you know it or not. Now, here's one example. And again, I'm trying to step out of political science a little bit to generalize, because we generalize, right? We're scientists. I got two dog trainers here, and they had I don't know if they still have them, but for a while they had these shows on, and I was watching these when I first got a dog, right? And so we have Cesar Millan, and Cesar Millan comes in and he tells you dogs have an innate social structure. They live in a pack and they assume a place in a hierarchy in the pack, and in order to train your dog, you need to assume the role of the alpha, the pack leader, right? You've got to be the leader of the pack. And so he comes off, his training method is based on a dominance theory. right? Of you have to be dominant in the pack. And so what he's doing is he's explaining the unobserved. What the heck is going on in that little brain in there, right? And how are they thinking? And we really can't observe that, but he's got this dominance theory that he works off. Meanwhile, Victoria Stilwell doesn't play that game. She goes off of positive reinforcement. She says, look, the way you affect the dog's behavior is you make sure that you very consistently reward good behavior. You make the desired behavior something that you consistently reward, and you understand how, and she talks to owners about how they're acting in response to what dogs do and how that's affecting their behavior. And both of these, the reason I bring these up is both of these folks work. I mean, both of these theories are fairly valid, and they sometimes, and a lot of times they lead to very similar things, but other times they lead to divergent ones. And you wouldn't necessarily think of this, even though I don't think Cesar Millan ever used the word theory, but he definitely has an explanation of what's going on in that dog's head, and then he acts on that. And so the key thing in here is that the theory is about explaining something you really can't observe, or something that's underneath the surface, and it leads to predictions. And this is what's so important. How do I get my dog to stop chewing on my furniture? Well, that you need a prediction. You need to predict what the cause is, and what causal factor you need to change in order to get the desired outcome. And that's a big role. You need to explain the behavior in order to predict what a change in the inputs or stimuli will produce in it, right? And so theories are important. And I don't know, I hope that kind of puts it in a more intuitive context. Okay, now hypotheses. What are hypotheses? Hypotheses are testable statements about the empirical relationship between cause and effect. And this is, in terms of storytelling, this is something we should be able to observe if the story is true, or this is a implication of a theory, right? Because theories are stories. And the thing about hypotheses is they're both predictive and testable. So when you work off of Cesar Millan's social dominance, he'll basically, every time he is saying, look, do this and this will happen, that is essentially a hypothesis, right? About what observable things will happen, if you, talk sternly and look your dog in the eye and don't let him go through the threshold of your door before you, right? And that's part of the dominance, right? You go first, you don't let them follow you, that kind of thing. And so he has everything he's saying is basically a hypothesis. And it's predictive when I'm saying, all right, here we go. This is what you can do to change behavior. Now, in IR, we don't change behavior. We don't experiment with states, and we don't, tweak things to prevent a war. We're generally trying to explain them. We might make policy recommendations, but we're trying to figure out what's right. We're trying to, we're scientists. We're trying to figure out, hey, which of the many theories and explanations that are out there, and there are often many rival explanations. We're trying to figure out which one is more valid, right? Which one explains what we're interested in best. And to do that, we test them, right? We test them against the historical record, because a hypothesis, that's the second thing. It's testable. I can go out and look at the world and say, all right, maybe I can't directly observe the theory or what the theory says is going on, but if the theory is correct, we should see these observable things happening, right? When we should see relationships between variables and data. We should see, in particular cases, one outcome versus another, right? We should be able to use this, not just, and we can basically try to predict the past and say, all right, this condition happened here. This is X. It's supposed to produce Y. Historically, when we've seen X, do we also see Y as far as generic conditions? So That's a big part of and where you most frequently encounter them is in the idea of testing theories. Now, hypotheses, here we get a little bit more into some terminology. Hypotheses and theories too talk about variables, right? And so when we're talking about cause and effect, right, which is how we don't like using that term, by the way. So we're trying to move you. I'm trying to move you in this direction using these terms. But let's just start with your understanding. There's cause and effect. Okay, the cause is the independent variable. It's not the first thing listed here, right? That's the thing that's going to have an effect on that's having an effect. Now, the effect is the dependent variable, right? And that's the variable that, as I say, represents the effect in a causal explanation. That is what you're trying to explain, right? So if you're trying to, if you're talking about causes of war, well, you're trying to explain what causes war. War is your dependent variable, right? That's the thing you're trying to explain. The independent variable is often, when you talked about in theories, right? Whenever you do empirical research, it's always an independent variable, right? Very often when people are using theories instead of, a lot of times they'll have independent variable as the term. They often use the term explanatory variable, which actually is somewhat more intuitive for you, right? Because that's the variable you think explains the dependent variable, all right? And so always remember it, and if you have trouble with it, I always say the way you remember the dependent variable is, well, what's the value of the dependent variable? It depends on the independent variable, right? Why do we call the independent variable independent? Because we aren't explaining where it comes from. This is the starting point. And so we just observe, there's an arms race. Is there war? Right? We're not explaining why is there an arms race, right? If we wanted, we could say, let's make arms races the dependent variable and explain where that comes from. But then we need other independent variables. Clear as mud? I hope. So these are very important terms. You'll see them a lot. Less important or less commonly used, we do have another two categories of variables. One is an intervening variable, right? Maybe there's a variable that acts as a go-between or mediator between the independent and dependent variable. And so, that sometimes comes into play. Maybe the story being told is a little more complicated. There are also antecedent variables, and these are variables that occur prior to other variables and may affect some of the independent variables. And so we can talk about antecedent variables. The big thing, though, you got to walk away from here with understanding what a dependent variable is and what independent variables are, or explanatory variables. And you got to, when you see, there's no difference between an independent and an explanatory variable. And those are terms that you really want to get used to and understand when people are talking about them. Now, just to give an example to end here with a little example of how this is all supposed to come together, right? The general story is you try to explain the world, you develop a theory. And a lot of people don't like theories. Theory sometimes has this term, oh, that's just a theory. It's like, well, no, anytime you are telling me that there's a link or something's happening, you're developing theory. You just might be doing a crappy job of it, right? Not owning up to what you're doing. And so that's what my reaction whenever anyone runs down theory. I'm like, well, if you have any explanation about how the world works, guess what? You just might be a theorist, and a crappy one. I just went a little, you might be a redneck innuendo there. Okay. Protectionist theory. That's not a great theory. And I picked this because I don't want to go down, because not everything is realism, liberalism, or constructivism. These grand theories. Anytime you have an explanation, it's a theory. So we have a lot of what I call kind of the mini or the practical theories that are out there. Protectionist theory, because protectionists are telling this story. They have a story. And their general understanding is that, hey, exports are good because they support American jobs or home country jobs, because they're protectionists in every country. And imports are bad because they take them away, right? And so with that in mind, the idea is trade deficits, where there are more imports than exports, hurt the economy, and we could flesh that out a little more that they take away jobs, that they hurt jobs in the economy, or you could just say it hurts economic growth. But this is a story that's being told. Well, all right, the hypothesis then. You look at that and you go, all right, well, that's your story. Let's see if it holds water. Let's test it. And we need it. We need a hypothesis here. And because there's a lot of different observable things, right? We could look at a lot of things around this story that this story explains. And so you can have multiple hypotheses out of a theory. And one of them is there is a positive relationship between the U.S. trade deficit and U.S. unemployment, right? That would be, a quantitative empirical hypothesis, right? If that's the case, and what? And so with that in mind, we go and we can look at the data, right? And hey, let's look at the data. Now, okay, this cuts out at 2008 because I made this slide a long time ago, and I don't feel like updating it. But you can, and hey, you're graduate students. You can, if you want to look at it, you can get this data from the Federal Reserve Economic Data Bureau of Labor Statistics. Has the FRED data has they have a lot of economic data. And the Bureau of Labor Statistics gives us our unemployment rate. And here we go. We got the blue line is the unemployment rate. The red line is the trade deficit. If the two were related, right, there was a positive correlation, meaning that means that when one goes up, when trade deficits go up, we should see unemployment going up. Is there just eyeball this chart? Is there a relationship? Well, sometimes the two lines move in the same direction. Circa, let's see, 1984 to 88, it looks like they moved in the same direction. The trade deficit came down, unemployment came down. But hey, 1990, basically from 92 to 2000, they went in the opposite direction, and then they went together, and then in 2008, they went in a different direction. I can tell you that you can do statistical analyses, right? We could do a correlation coefficient. We could run a regression. We could do a lot of stuff to quantify this and get, the probability, statistical significance, and we could do a lot of stuff with it. Or hey, we could eyeball the data. And I think if you eyeball this, you come away with, there's not a real correlation here, and there isn't. I can tell you, if you run the stuff, there isn't. And so this idea is not holding water. Now, the great thing is you go deeper into it. You can go, well, maybe there's an intervening variable, or maybe there's other things. But this is how we use hypotheses. I'm just trying to show you that, you get a theory about the world, an explanation of the world, you develop a hypothesis that's an observed relationship, something that should be true if that explanation is valid. And then you go and test it, and you say, boom. By the way, if you read the Dictator's Handbook, and a lot of, if you're in my course, it's probably assigned to you, that, they develop a theory, and then throughout the book, they are constantly testing hypotheses, right? I mean, all sorts of things. How many people die in an earthquake based on the size of the coalition in a country? And I mean, they just have, and this is at one point, Bruce talks about a student saying, well, this is like a theory of everything, because they just generate so many testable hypotheses and test them. And generally, they find that it holds water. And that's what they're doing. And that's when you start getting some confidence. Notice, though, and this is getting away from just the basics here, but we never prove a theory. We test a hypothesis, and we either, it either supports the theory or doesn't support it. And when, I won't get into how one theory beats another one too much, but that you never completely prove a theory, right? And you test it and it gets support. But theories always fail. I mean, they're generalizations, and there are always cases, and there's maybe something we don't know, but there's always a mixed bag. And so that's why you do a lot of testing and you try to test the main point, right? And so I think here, sure, there may be other things to talk about for protectionism, the quality of jobs, and you've got all sorts of other things, but their primary idea that there's a relationship between the employment and trade deficits just doesn't hold water. And so we have to deal with that and refine our understanding of the theory, or reject it like I tend to do. But I have a point of view on that, right? But and the thing is, if you have the point of view, you don't just stick to it, you test it. You try to find validation for it, or try to find empirical support. And sometimes, though, you have an idea that gets totally falsified. That's life in science. All right, that's all I got for this presentation. Thank you.